doing relations. At the end of the relations, we have composition of relations. In the composition of relations, let us understand how do we write the composition of relations, and then we will start the first part of calculus. It is functions. First part of calculus, it is functions, and after functions you will have limits, continuity, differentiability. And before going to the functions, let us finish up this last part of relations. Let me share the screen. Are you listening to me?
Yes, sir.
Yes, boys and girls. Yeah, this we finished yesterday. The next one. X be a family of sets and R be a relation on X defined by A is disjoint from B. Then R is A is disjoint from B. Then R is. First of all, what is the meaning of disjoint? Nothing is common. Disjoint means if you have a set like this, another set like this, disjoint sets means nothing is common to both. And we call it as, in set notations we have learned, A intersection B is equal to 5. Then if you get doubt what is the joint set, in the name itself we have the meaning of it, joint. Something is common to both. For example, this is one set, this is another set. Then in this case, A intersection B is not equal to 5. Understand that. So when A intersection B is equal to 5, it can be written as B intersection A also. So we can say that it is perfectly symmetric. So it cannot be reflexive and it cannot be antisymmetric and transitive. Only A and B can be interchanged. So only one option holds good there. Which is the option, please? It is symmetric. Okay.
सर
Yes.
विदाउट वेन डायग्राम नहीं हो सकता.
लिखा ना नीचे.
हाँ यस सर.
That's what is written in the, just for your better understanding, I have drawn the Venn diagram, and this is the notation we use. A intersection B is equal to 5, which can also be written as B intersection A. Next, R and S be two non-void relations on set A. Which of the following statements is false? You have to take false statements from this one. Let us check. R and S are transitive. R union S is transitive. Let us check it out. Let us take a set A, which is 1, 2, 3. And it is common sense, you will understand after me doing this problem. Let me take R from this one. R on A. Let me take R on A, that is a relation I am taking on A such that it is transitive, because I need a transitive relation from the options here. So if it is transitive, what happens? I'll take 1, 1 for example. and 1, 2. That's all. Simple one, let us take. 1, 1, 1, 2. 1, 1, 1, 2 means this 1 is common here. If you eliminate 1 in between, then you'll get 1, 2. 1, 2 is already there. So it is transitive only. Similarly, let us take B is equal to something like A, B, C. Let me say. Then R on B. Otherwise, let me say R dash. Yes, no. He has given it as S. So let us take it as S only. S on B. It should also be transitive because both are transitive relations. Let me write this as AB, BC, B removed, AC. So these two are transitive relations I have taken. Now let me write R union S. What is R union S? Union means it takes every element without repetition. 1, 1, 1, 2, AB, BC, AC. How is it possible that it is transitive? Not transitive. Is not transitive. Okay.
Sir,
Because it consists of 1, 2, 3 and ABC also. And you cannot write the relation transitive for this one. Yes, please.
So,
Yes.
here,
First Rishikesh. पूछो ना जल्दी.
so what else can I ask?
Yes.
So मतलब मुझे ये समझ नहीं आ रहा वो R on है S on भी वो क्यों ऐसे लिखा है मतलब R union से वो समझ वो रिलेशन मतलब R on A क्यों ऐसे लिखा है S on B क्यों लिखा है वो नहीं समझ आ रहा.
Now you have to take a set. Now first set A is taken. I have taken a relation on set A. This is a part of A cross A. Relation is always a part of A cross A, no? A cross A is nothing but
हाँ
1,
yes
1,
sir.
1, 2. And so on, finally 3, 3 like that. You must take a part of it, no? That is the reason why I wrote R on the set A means it is a relation defined on set A. Let me do one thing, otherwise what I
सर
do.
पर आपने इधर सब वैल्यूज नहीं लिख लिए है ना R on A का.
सबका क्यों लिखते हैं यार? हमको ऐसा एक ट्रांसिटिव रिलेशन चाहिए. And what is the definition of relation? You're asking me a surprising question at the end because relation is subset of A cross A. How do you write all of them? If you write all of them, that becomes the Cartesian product. This is the product A cross A. It contains all, but I have taken one relation in this one, one subset in that one, which I must have as a transitive relation. That is why I took it as a transitive relation. 1, 1, 1, 2 is 1, 2 again is containing. So it is a transitive relation.
हाँ now I get it. Sorry sir.
Similarly, you take another one on A itself, otherwise no problem. I'll be taking this as something like 1, 2, 2, 3. If I take now, to make it transitive, what is the other element should be included? Anyone? To make it transitive, what is the other element should be included in this one?
1 3
Respond.
1 3 1 3.
Now it
Hello
is
sir, can you hear
transitive.
me?
It is transitive. 1 3 is also present. Okay. Now, R union yes. You have forgotten the entire set theory. What I feel. R union yes means you have to write all the elements without repetition. 1 1. Come on, tell me. 1 2 without repetition. 1 2 is there. We
2
don't write.
3
2 3
1 3.
1 3. Now, just if you see, this is not transitive. Check it out, please.
Not transitive, sir.
Why?
Because it is not
1 2.
satisfying the definition.
1 2 does not belong to R union S. Therefore, it is not transitive. So the first one is wrong. This is a false statement. We have to recognize the false statement. The rest all are correct. You can proceed like this only. The rest all are correct. You can proceed in the similar manner. Yes, I am erasing this. Moving forward. Okay. Composition of relations. This is to be understood carefully, please. Very, very carefully, because you'll get the same composition of relations, similar concept you'll get in composition of functions again. Functions again. So here, just listen to this. I'm explaining anyway. I'll take an example and explain. Let R and S be relations from set A to B and B to C respectively. Then we can define a relation S circle R or SOR from A to C such that AC belongs to SOR if and only if there exists B belongs to B such that AB belongs to R and BC belongs to S. This relation is called the composition of R and S. Listen to me carefully, please. I'll explain this through a practical example so that you will also be comfortable. Let me take a set, another set B, another set C. I have taken one set A, another set B, another set C. So here I am taking the case of manufacturing of a car. A car is to be manufactured. For this, all the machinery and I'll say this as simply parts. Parts are needed to assemble. All these parts are to be manufactured from the raw material. Raw material, to manufacture the body, it is taken from iron. To manufacture the tires, it is taken from the rubber. To manufacture the machine or a motor or engine, whatever, they are all taken from the raw material. So to manufacture a car, the process starts from the raw material. The process starts from raw material. So from raw material to parts, and all these parts assemble to manufacture a car. So you have to understand that this, we can say, if you see this, car manufactured from the raw material via parts, via all the parts manufactured. So we can say car is manufactured from raw material. Finally, can we say like that? car is manufactured from the raw material. I can say like this. Now, what is the association here? This you can see, now you understand this. Let R and S be relations from set A to set B. This is R, please. This is R, A to B. This is S. Just see this, B to C. Then we can define SOR, SOR, SOR from A to C. SOR means you have to see from the right side. Otherwise, you understand it, the car is manufactured from the raw material. So we finally define this in this way. Implies SOR is mapping from SOR is mapping from A to C. This is called composition, please. Little confusing, but if you see this properly, you will understand very easily. There is a relation R from A to B. There is a relation S from B to C. And for the example's sake, I have taken the case of car. A car is to be manufactured from the parts, and these parts are to be assembled to make the car. And these parts are to be manufactured from the raw material. So I can say that this car is finally manufactured from the raw material only. We can say that. So this R is related from A to B and S is related from B to C. Again, SOR, car is made from raw material and which is mapping from A to C, This is what you have to understand. While solving this type of problems, always remember, while writing the mapping, you take the mapping of R. Mapping of R is A and mapping of S is B to C, and A to C is the final result. So this is what you have to understand. Please let me understand whether it is clear or not. This is called composition. This is called composition, and if the composition, then you must ask me, sir, the composition is possible for every relation like that? No, the composition is not possible always. You must have the composition like this. Here S is mapping from R is mapping from A to B and S is mapping from B to C. There must be a common set in between them like this. Like what? The range of R is B and the domain of S is B. Are you there, everyone? Please listen to me. I'll mention it separately like this. R is mapping from A to B and respond. S is mapping from anyone, please,
B to C.
in the class.
B to C. B to C.
B to C. For this, the mapping or the composition is possible. The reason, the range of the first relation must be equal to the domain of the second relation. Then only SOR is possible. SOR is possible. What does it mean by SOR here? The composition of R and S, it is to be taken like this, SOR, and the mapping is from A to C again, like this it is. This is called composition. For more clarity, let me change the color and show you this one. SOR, like this. And while writing the sets, sets ought to be mentioned from A to C like this. Now, anyone in the class, what is the basic condition for SOR to exist? What is the basic condition for SOR to exist? The
Sir,
range of R must be equal to the domain of S. The range of R must be equal to domain of S. Then we write SOR maps from A to C. Now, do you tell me ROS is possible or not? Anyone in the class? ROS. Then how
No,
to see
sir.
yeah,
for
can be
ROS?
made.
How to see for ROS? You have to write yes first. Yes is B to C and R is, tell me what is R here? A
A
to
to
B.
B.
A to B.
Now ROS we need means R to S, it's okay. We will write it, no problem. R to S, let us write like this. Now the basic condition, what I explained you, the basic condition, what I explained you is that the range of the first relation must be equal to the domain of the second relation. Is it equal?
No, sir.
No, sir.
No, that's the reason why you tell me whether this ROS is possible or not.
No.
Not possible.
No, not possible. So ROS is not possible. So always remember the composition is not always possible. Composition is not always possible, and the composition is to be seen like this: R maps from A to B and S maps from B to C, and SOR, that means from right side to left side, you take the condition, you take the composition, right side to left side. SOR maps from A to C, again A to C, from left to right, left to right. This is what I have shown you. Car is manufactured from raw material and it is done from A to C. This is what you have to understand, and little more attention is needed. Little more attention is needed. It is simple only. So car is manufactured from the raw material. Let me write like this. So car is manufactured from the raw material from A to C. From A to C, like this. Okay, SOR A to C. SOR A to C in the anti-clockwise direction. The same process we follow even for the functions also. You will get the same for functions. You will get the same for functions. There also you will have the same conditions, no difference at all. Only the definition of function differs. Okay, now let us take an example, and after that, if you have still more doubts, I'll explain it. I'll explain it, no problem. Just say this. Now, let us see the example here itself. Rishi, you read this. If A is equal to,
A is equal to 1, 2, 3. B is equal to A, B, C, D. C is equal to P, Q, R, S. B3 sets such that R is equal to 1, A, 2, C, 1, C, 2, D is a relation from A to B. And S is equal to A, S, B, Q, C, R is a relation from B to C. Then SOR is a relation from A to C, given by SOR is equal to 1, S, 2, R, 1, R.
yeah, let me show you that separately. I'll be writing that so that you have the problem next to it, you have the problem. But anyway, we will do this first. Okay, so let me write first S maps. This is R. R is defined from A to B. First of all, R is defined from A to B. And Ananya is not there in the class today.
Sir, I'm there.
And S is mapping from B to C, please. What is the technique I taught you while writing the composition? While writing the
ROS.
composition from right to left, you move. Okay. And see whether the range of the first relation is the domain of the second relation or not. Yes, it is there. Then simply moving from S to R, you continue the direction from A to C by removing C. That's it. Okay, here it is possible. So now you tell me implies. You tell me, please. I'll write. When you say I'll write, please tell me SOR.
SOR is such that A is mapping to C.
Yeah, A maps to C. Okay. Now he defined it. Let us write that now. Let us write that first. Let me write R first. What is R given? Do you tell me that, Ananya? Tell me R, please. 1A, 2C.
2C, 1C, 2D.
2C, 1C, 2D. Correct. Do you tell me yes, please?
AS, BQ, CR.
Yeah. Now, without seeing that, let us write now SOR. SOR is equal to A to C, no? A to C. SOR A to C. What is that I said? 1A, yes. Common element is to be eliminated. Just see that carefully. Understand this. Understand this.
1S.
This A to be eliminated. Are you there, everyone, please?
Yes, sir.
Yes, so we are there.
The range and the domain element must be eliminated. The range of the first relation and domain of the second relation is to be eliminated. Then what is that you get? You will get 1S here. 1S. Okay. Similarly, what is the other one here? You have to see for the common elements there. Here C, you have C here. Is there any more left over? 1C is there, and here also you have C there. 2D is there, D not there. That's it. Come on, tell me now.
1S. 2R1.
1S,
2R.
2R, you're right, 2R,
1R.
1R. That's all, no? That's all.
Yes, sir.
This is what the composition is. This is what the meaning of composition. This is how we write the composition of two functions. Okay. Now you ask me any doubts in this one, please. In this part.
Sir,
Yeah.
it's just a relation from A to C, no? We got there.
Which one? Correct. Relation.
Yes, sir.
It's a relation.
Yes, sir. Thank you, sir.
It is called composition. It is called composition. Now, this S circle R maps A to C exists. It doesn't mean that it need not always be R circle S also exists. It need not be. Okay. Now, let us continue for the inverse. Inverse means what? S circle R whole inverse. That is inverse of this. You have to split it always from the right side. In further topics also you'll get the same. Always when you are splitting a bracket for inverse, transpose and all this you'll get further, you have to split it from right side. Reason you'll understand. R inverse circle S inverse. R inverse circle S inverse. Then let us write R inverse. Anyone please do help me out in writing R inverse here. Let us do mind calculation here. What is R inverse for this? A1,
A comma 1.
C2,
C,
C1,
2,
D2.
C1, D2.
That's it. What is S inverse?
SA, QB, RC.
That's it. You have to write the R inverse circle S inverse. That means you have to start from S inverse. Right side always. S inverse. What is S inverse here? SA. What is R inverse here? A1. SA, A1. What is to be eliminated? I'm writing it here. SA, A1. What is to be eliminated? This A is to be eliminated. What is the remaining? S1. Are you there, everyone?
Yes, sir.
I'm writing for inverse, please. S1. What is inverse of S circle R? Inverse of SOR. SOR whole inverse. Not 1S, it is S1. That's what you got it. S1. Are you there? Just you.
Sir.
Yes, sir.
So this is R inverse, S inverse we write. And if you write SOR whole inverse in the split form always to be split from right to left. Always to be split from right to left, please. Now I'll take one more for your better understanding. SOROT whole inverse. Anyone? T inverse O
R inverse, O, S inverse.
ROS. These are called composite functions. Let us work out the problems. If you have any doubts, you ask me. Otherwise, I'll move on to the next part of it. Next part means problems.
So can you show that how that SOR inverse came that you solved no for S inverse OR inverse, that one. By this example you solved that I didn't get, sir.
What is R inverse? You tell me here.
A1
First element, you tell me
C2.
first element.
A1
A1. What is S inverse?
SA.
How to write R inverse circle S inverse? Start from S inverse only. Right side only you have to start. So, what is the
Yes,
first
sir.
element for this?
SA.
What is the first element for this?
A1.
That's what I wrote. SA A1. The range and the domain should be cancelled here because they're equal. And what is that remaining?
S1.
That's what. What is the inverse of SOR? What is the
R
inverse of?
inverse O S inverse.
No, here.
That's one.
What is the inverse of S circle? SOR whole
S1.
inverse.
S1.
That's what you got here.
Yes, sir. Got it, sir.
If R is a relation from set A to set B and S is a relation from set B to set C, then the relation SOR, please. Tell me the answer directly.
A to C.
A to C. That's what we did now. R is a relation from A to B and S is a relation from B to C. Now, first of all, while writing SOR, what is a hint given? Take it from right to left. There's no doubt in it. Right to left. But while writing the mapping, whether it is possible or not, how to check it out? You have to check the range of the first relation must be equal to the domain of the second relation. It is equal. It is equal, and hence you can eliminate that and you write A to C. This is what just now I explained. So start from yes, right side, yes, O, R, from A to C. So what is the answer here? Is from A to C. Now, anyone in the class, do you tell me ROS is possible or not?
No, sir.
ROS
No,
is
sir.
not possible because S maps from B to C and R maps from A to B, and it is C, it is A. Not possible. Not possible. If they are equal, then only it is possible. Next, what is a straight formula here? Anyone, please? S circle R whole inverse, please. I ask you to split it from right side.
R inverse O S inverse.
R inverse O S inverse. That's it.
So why they have given that left part?
Pardon me?
Why they have given that left part? That R intersection A cross B.
Oh, A cross B, he has taken two sets A and B. And this is A cross B, this is B cross C. He wants to mention that these two are common. If they are not common, you cannot have the composition.
Yes, sir.
What he means to say by that, I wrote it as R maps from A to B. He mentioned it as A cross
Yes, sir.
B to C. These two he wants to show C.
Yes, sir. Got it, sir.
So in the next problem, what I do, I'll show you this through Venn diagram so that you'll better understand it. Now, let us understand. R be a relation from A to B. That is, AB belongs to R, A less than B. Then R circle, R inverse we need. Come on, tell me now. Let us write R now first. Anyone, do you tell me what is R in this case? A less than B is the condition. So, take 1. You have to choose all the greater numbers than 1. 1,
3 and 5.
1, 5. I hope everyone understanding that. Take
Yes, sir.
number 2 and take all the numbers greater than 2. 2, 3,
2, 1.
2, 3, 2, 5.
Take number 3. Ananya, 2, 1, you don't get beta.
Yes, sir. Yes, sir.
If you take 3, no, you must have
3,
only
5.
If you take 4, no, you will have
4,
only
5.
4, 5.
That's all. This is defined as R. Now write R inverse, please. 3,
3,
1.
1, 5, 1, 3, 2, 5, 2, 5, 3, 5, 4.
That's it. Now, let us understand, first of all, whether this composition is possible or not. Because he is saying that R is mapping from, why I'm using this mapping form in functions, you'll get the same. A to B, and obviously R inverse maps from B to A. Are you there?
Yes, sir.
Yes, sir.
Inverse means the domain becomes range, range becomes domain. Okay, now what I need is RO R inverse. What I need is RO R inverse. What is that I said? Use for write RO R inverse. Start from R inverse, okay, and go to R, then check whether these two are equal or not. Yes, these are equal. Eliminate them and continue writing the mapping. It maps from A to A. Correct or not?
Yes.
Now, anyone in the class, do you tell me R inverse O are also possible or not? Anyone, please.
Yes, sir.
Possible.
R inverse O R is also possible, but it maps from B to A, B to B. Because it is A to B and B to A, it is possible. But in the previous case, it is A to B and B to C, no? So R
Here only
inverse
yes.
O R also possible, but it maps from B to B. This is what you have to understand. Now, let me write this and I'll show you anyway through the Venn diagram so that you will better understand it. Now, what is that we need according to the question? R O R inverse. R O R inverse is equal to, you have to delete the common element of R's range and R inverse domain. R's range and R inverse common domain. Okay. That is, just see this. 3, 3 is there. Eliminate. 5, 5 is there. Eliminate. And one more 3, 3 is there. Eliminate. And any more 5 are there? Yes. 5 is there. Eliminate. 2, 3 is there. Any 3 is there? Yes, it is there. Eliminate. Any 3 is there? No. Any 5 is there? Yes. 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 Eliminate it. And 3, 5, yes, it is there. It is there. 4, 5, yes, 5 is there. Now, let me understand.
Sir,
Yes, beta.
2, 3 का first R inverse का first से हो रहा ना 2, 3 and 3, 1.
हाँ हाँ, अभी बताओ 1, 3, 3, 1 में 3 एलिमिनेट करके बता.
1, 1.
हो गया. और 3 का और भी है, ये 3 एलिमिनेट करके बताओ. 1, 2. करेक्ट है ना बेटा?
Yes, sir.
Do you have that in the options 1, 2?
No, sir. 1, 1 भी नहीं है.
मतलब कुछ गड़बड़ है. अभी देखना एक बार फिर से. हमने जो लिखा वो करेक्ट है कि नहीं चेक करो एक बार. R circle R inverse maps from B to A, and what is that we need? You have to write just a moment. Oh, let me show you. So I have to write one below the other. Let me check. Now, let us see that once. इधर देखो बेटा. अभी हमने क्या किया था? Now you compare it with this one and then we will write. Now you just understand this, please, every one of you. Now what is R here? Maps from A to B, na?
Yes, sir.
And what is S here? B to C. Correct again? Now S circle R. Yes, circle R from right side. Yes, circle R maps from A to C. Correct? Now let us replace this in the present problem. This is R is mapping from A to B, and R inverse maps from, come on, tell me please, B to A. Correct or not? Then we
Yes,
wrote
sir.
R inverse R. What is that he needs? R inverse R. According to this, please. S comes first. So R inverse is circle R. Maps from A to A. Correct or not? And you tell me, anyone please. This is in place of S, you have R inverse. In place of R, you have R, of course. So R inverse circle R maps from A to A. Now, if you want R circle R inverse, R circle R inverse, this will become, you have to count it from right side, B to A. This becomes B to B. So let us check it out now. Now let me see. Yeah. Now see this please. अब देखो अभी डेफिनेशन पे आ गया हमने. ये बता. Please respond. Little this relations you have to more theoretical. That is why reason why I gave even an example also, but that may not be effective, that much effective. Now you tell me what is S circle R, please. S circle R, please. S circle R. You respond.
A to
A to
C.
C.
A to
A-
C. Come on, tell me now. What should it be for? You transform the same to these two.
R inverse
to A.
OR.
R inverse OR. But what he is asking there?
ROR inverse.
ROR inverse.
So let us reverse them like this. R inverse, write it here. That is nothing but B to A. And R here, A to B. Now it will be clear. Just see. Come on, tell me now. We need ROR inverse. Anyone? Do you tell me the mapping now? ROR inverse. ROR inverse.
B to B.
B to B. So what is a common element to be eliminated in this case now? A. A is the common element. A is the common element to be eliminated. This is A. So now you have to start from B to B now. B to B you must get. So B is 135. B is 135. Your mapping must be between 135 and this one is A is to be eliminated. Let us check it out. Now from R inverse B to A, please. This is 3 1 1 1 1 3. Now like this you have to see. Come on, see this now, please. It will be more clear now. Just let us do it like this.
1 to 1.
This is to be eliminated. Similarly, this is to be eliminated. That's all for this. Now, here also you have
1 to 1.
1 to 1.
1 to 1.
First one also.
First one also. And here 2.
Is 2.
Here also 2.
Yes, sir.
Here also 2. One more 2 here. Of course, they will be repeating, I think. Next 3. This is 3. No 3 is present. 5, 4. 4. Come on, tell me now.
3, 3.
Just a moment, beta. Just a moment.
3, 3.
हाँ बोलो बेटा.
5, 5.
5,
5, 5.
comma 5. 3, 5 is also there. Let us write it in order. 3, 1 के लिए 1, 1 हो गया. ये 1, 1 हो गया. 3, 5 आएगा. है ना?
Yes, sir.
ये हो गया अभी. ये 1 का बताओ.
5, 3.
5,
5, 3.
5, 3.
5, 3. Again,
5,
5,
5.
5.
that's good. 5, 5.
बस sir.
3, 3.
बाकी repeat से.
Repeated. Okay. 2, 2 है तो 3, 3 है उधर लिखने की जरूरत नहीं. 3, 5 है वो भी repeated. 5, 3 repeated, and 5, 5 repeated, and 3 eliminated. 5, 5 repeated. 4, 5, 5 repeated. That's it. Little complicated. You have to understand there. So how do you remember it? Whatever you are getting, please, final conclusion, please, final conclusion. Whatever you are getting on right side of the composition, whatever you are getting on the right side of the composition, take the range of it, take the element in its range, take the elements in its range means the element in the range means its second element, and search for the same element in R, search for the same element in R, and then eliminate it to get the composition. Is it clear, please, every one of you?
Yes, sir.
Yes, sir.
Let us try it. Just a moment, please. As Rishi was saying about the Venn diagrams in the previous class, is it not possible to understand this without Venn diagram? He said no. Now, with Venn diagram, how comfortable you will be? Just see this. Let me write here. This is B. Let us see the next problem. Next problem is containing R given directly. Here also the same. Here also the same. Now see this. Let me close with this one, and we will start functions in the next session, that is after the break. Now this is A. This is B. Now what is A given? 1, 2, 3, 4. What is B given? 1, 3, 5. What is R defined? Come on, tell me please. What is R defined? This is R. What he said is
Yes, sir.
less than A, less than B, he is saying. Correct or not? That is 1 to 3 is one relation. 1 to 5 is another relation. 2 to 3 one relation. And 2 to 5 another relation. 3 to 5 one more relation. 4 to 5 one more relation. This is defined as R, please. This is defined as R. Anyone, do you tell me what should be R inverse now?
B to A mapping.
That's it. B to A mapping. That means I'll show you like this. I'll show you like this for your better understanding what I'm doing. I'm creating one more A here for you to understand RO R inverse. Come on, tell me. What should be written here? 1, 2, 3, 4.
3, 4. Yes.
Yes, please. Now, B to A, no? B to A. There is no relation for 1. Come on, tell me. If you tell me, I'll write, please. 3 to 1.
3 to 1.
Come on.
3 to 2.
Good. Any more?
5 to 1. No, not for 3. Now 5. 5 to 1. 5 to 2.
5 to 3, 5 to 4.
3 and 4. 5 to 3 and 5 to 4.
Correct. I will separate it and write it here. I'm separating this. I'm writing above. This one, what I'm doing, I'm showing this separately above. What is this relation, please? Come on, tell me. What is the name of the relation? R.
R.
What is the name of this relation, please? Respond, please.
R
Respond.
inverse. R inverse.
I'm taking efforts here for you to explain in a better way. R inverse.
R inverse.
What is that we need? RO R inverse we need. RO R inverse. What is that RO R inverse now? Just now we have seen. See the continuation there. See the continue. Which option we got the answer? C.
3.
3. Just if you see carefully, again it is to be defined from A to A or B to B. You tell me first of all how RO R inverse is to be defined. RO R inverse is to be defined.
A to A.
Whether it is A to A or B to B, Ananya?
A to A. Yes, sir. A to A.
B to B, no, we got
B to B.
B to B. Now, B to B you have to see. B to B you have to see. Now, see the common elements here. Just you will understand now like this. This is 1, this is 1. What is the common element? 3. That is why 1, 2, 3, 1, 2, 3, 3, 3 will be one option here. See this. Check this. I repeat. 1 is mapping to 3 and this one is also mapping to 3. It is 3, 3. Are you there, everyone?
Yes,
2 is
sir.
mapping to
Yes,
3.
sir.
Again, 2 is mapping to 3 and 3, 3 is one option. It is already there. Similarly, 2 is mapping to 5. 2 is mapping to 5 and this 5 is mapping to 2. 5, 5 is there. Just check it out. Okay. And 2 to 5 and 5 to 1. 2 to 5 and 5 to 2. 2 to 5 and 5 to 2. 3, 5, 5, 3. Like that you have to see. Just this is 3, 5. This is 5, 3. 3, 5, 5, 3. 3, 5, 5, 3. Like this you have to see. So this is how you can understand even through Venn diagrams also. Let us close this with the next problem, this simple problem. I'll leave it, then after that I'll leave you. Just see this. Come on, you tell me, you recognize the answer first, directly. Let me write. R, please tell me R given, please. Let me write R first. What is R? 4, 5, 1, 4. Come on, tell me 4, 6.
4, 6, 7, 6, 3, 7.
Tell me R inverse, please.
5, 4, 4, 1, 6, 4, 6, 7, 7, 3.
What is that we need? R inverse OR. R inverse OR. So what is that I said? Start from right side. Right side is R here. Take the domain of it. Take the domain of it. Take the range of it and eliminate the domain from R inverse. Now let me show that through arrow marks here. Because right side you have R here, start from R. Right side you have R here, start from R. Take its range and map this to its domain. Any more such? 5 not there.
No, sir.
4 is there.
4, 4,
6 is there.
6, 6.
One more 6 is there. 7 is there. Come on, tell me now.
Sir, one more 6 is there. Sir, 7 is not there, no?
Oh, not there, beta, not there. Correct. 6.
6 and 6.
6 and 6. Come on, tell me the final answer.
The 4, 4. The 4, 4 is there in first one also.
1, 1.
Let me write one moment. Rishi, 4, 4, 1, 1. Yes. Yes, please.
7, 7.
7, 7.
3, 3. Option B.
That's it. This is to be practiced from your study material, please. I'll show you that. And you have to practice this one. Unless you practice and remember, you have to remember it till May, June 2022. May, June 2022. 1.5 year. 1.5 year more, you have to remember this. That is the reason why you practice it from the material, study material given to you. Okay. Okay, let's break for 10 to 15 minutes. Please be back within 10 minutes. Okay.